Hello, welcome to episode 142 in this series where I'm programming an NES game live on Twitch from scratch. Let's just get straight into it. I want to kind of fix a couple of things. In the last stream, we got the code working to do the export. The level was loading correctly, but the palettes were wrong, and also the palettes are writing into the wrong location. So if we go to the assets folder here, you can see that it's generating these meta tiles, which are correct, but the palette files that are being generated are for some reason being generated in that main assets folder. And I thought it was changing. I thought I had changed the directory, the current directory that we were working in, to be in the exports folder. Hey, MDTA UK. Does your asset tool still load palettes generated based on the meta tiles from tiled? Yes, it does. But the problem is right now there's nothing doing any sort of correlation of the palettes generated between the meta tiles. So what that means is it generates a bunch of palettes and it tries to keep them within the 3 color plus black background limit. But then it does not compare those palettes to one another to determine if there is a shared palette that could be used. So that's what we're going to need to look at here in a minute. But I want to first understand why the files that are being written are not being written in the right location. I know you added an explicit background color, but couldn't you explicitly set those palettes within tiled? Yeah, you could. So the meta tiles are compared to the 4 palettes you set and assigns them. Yeah, I mean, you could do that. I'm just not sure if the, like, if we do that where in tiled we are explicitly setting the palette that's used, I'm not sure if it would be something like where we would just numerically designate, like this is palette 1, or you could even maybe, yeah, you'd probably just assign the color palette by number. Well, yes and no. When you say I know where the palettes you need for the art used, yes, I know roughly. Well, let me think about that. You might be right. You might be right. The thing is, then you have to explicitly set it in the map. And how you'd set that in the map, I assume, would be another layer, potentially. Right? That's at least off the top of my head. Like, you'd have to have an additional layer, let's say, like this, and you'd have some way of choosing the palette, and then you'd select the area and specifically have your palette selected there. I mean, and that works. Let's think about what. So the upside to that approach, right, is that it's pretty straightforward. You just select your areas where you have to assign palettes, and you do it, and you're done, right? And it's just set, and it's fixed, and I don't have to calculate anything or look anything up or compare anything. The end. On the flip side, though, the downside to it is that you have to explicitly set it here, so you have to actually go through the process of setting it on the layer. If you don't set it on the layer and you forget, I'm not sure, the behavior would probably have to be that it would error out and let you know that it encountered an entry that has no palette selection on it. Additionally, if there was some sort of mismatch where the palette selection for each meta tile was not consistent, it would also have to generate an error. Because, well, I guess it could go with like a majority. Like if you have three that are the same but one isn't, it could just assume that you meant the one that you have three of and generate some sort of warning. And then you know, if you have two of the same, then it would just fail. So as I'm speaking, I'm also trying to. It's like I'm kind of rushing ahead to think of what other possibilities you might run into. Because, like, you could also say, well, then you could also explicitly set a palette swap and say, well, these tiles are the same as the tiles that are just the grass with no decorative elements on them, like they are, right, for all intents and purposes, but the color is different, so you could palette swap them here. But then how do you do that in tiled? Tiled doesn't know anything about the palettes, it just knows about the images. So you could just never make a mistake. Of course, right, that never happens. I'm always perfect in everything I do, so that's why I always, write my code with no error checking. If only users could be so careful. I mean, so the flip side, so then the other approach is that now that we're generating these meta tiles, we load up the meta tiles, we load up their palettes, and we compare their palettes, and we do a process where we essentially boil them down to the bare minimum, right? So if we imagine that we have, it was an unnecessarily faint line that just randomly decided to show up. We could imagine where if you have a set of palettes like this, we could go through and look for the shared colors that are used in all the palettes and say, well, this one and this one are the same, and and then this one and that one are the same, and then this palette for whatever reason is maybe just for the water, and it's got only one color, or maybe it's water and grass, and so it's only got the background color and the one color, and so we could consolidate that up into here, and then we'd have to eliminate that palette and then take whatever meta tile that is and remap it to this, to this palette over here. That seems like a lot of messing around with things, which is that's why I'm considering what you're saying so carefully, because in that sense, it is nice. And then what we could do is we could, literally just have the palettes predefined. I assume the person doing the art for the game is working to the color limitations. Could they include the palette? Well, yes, they are working to the color limitations, and I believe you have the background color explicitly stated too. Yeah, that was purposefully done because we discovered that if we don't, it can create some issues. So yeah, so if you look at this here, you can see these are the palettes that were selected. I dropped my phone. So these were the palettes that were selected for the work that he did. Well, palette issues are just in general problematic on the NES, and they're even more so problematic when you choose to do something like I did here, where we're trying to be freeform in terms of what we can actually accomplish background tile wise, and you know, but still be efficient in the way we store our data. So I guess the question just really becomes, how would we do this in tiled, like in a way that made sense with the tile layer? We have an image layer, we have a layer. If we have a tile layer here, we've got to place an actual tile on it. If we put that on top, can I do that? Can I switch the order? Yes. And then if I do this, this draws on top of that. Is there a way to make this? Oh, you can make this semi-transparent. So I can do this. See, that would potentially then work, maybe, where then what I could do is you know, have another. See, the thing is, I hate that it's got to be a tile set. I mean, it can't be an object because objects aren't grid-based. But like the idea would be, okay, well, you know, all of this, you're part of this palette. All of this, you're part of this palette, right? We just kind of drag like that. And then if we wanted to, we could say, you know, let me see what the palette looks like here. And it's like, oh, okay, right? That looks reasonable. And then we need to put this palette over here, right? That's kind of like what I think you're talking about, MDTA UK, where we can explicitly state that, and then if we need to turn it off so that we can just see what it looks like, we can do that, and vice versa. If we need to see where we've applied our attributes, we can do that too. Hey, UK Shadow 7. Taking away the guesswork for the tools. Yeah, I mean, yeah, that's a valid point. I mean, it might ultimately be faster and just more efficient to do it that way. And it's certainly simpler to code, because looking at what we would have to do. So I guess the real question then becomes, how do we designate these palettes? So if we, let me turn this off for a second. I want to erase what I just did. Can I can. Excellent. All right, I was wondering if it was possible to wipe all of that out in an area selection like that. So, all right, so we're, oops. Oh no, I erased. Okay. I had the wrong wrong thing selected. Darn it. Okay. This. Choose that. Choose that tile, and then let me just fix this. And fill that. Okay. Save that. So if we can explicitly name this palette. Yeah, no, I understand your thinking there, and I think that's a valid point. And probably the best way to ensure that we don't run into too many weird issues with the colors, because as great as it sounds that it's going to automatically figure some of this stuff out, the reality is probably more likely that we're going to run into weird issues as we move forward, where it automatically does something that is either wrong for strange reasons or whatnot. I mean, I think the way that it calculates, well, so, and then what it would need to do. Okay, all right. So this is kind of coming together in my mind. So then what it would need to do after that is it would need to know, okay, if this is the palette that you selected for that meta tile, when it goes to actually compose that meta tile. So let's go to that code for a second here. So when it goes to, so when it calls this, before it calls this, it calls this load image palette, where it iterates over, is this it? Is this right? Initial sprite. I'll just iterate through here. Final palette. Okay, so yeah, so if we do that, when we come into here, right now we're generating the final palette for the meta tile image ahead of time. What we really want to do is load image palette, convert image to indexed, load image palette. Oh, okay. So actually we don't have to do that much. What we would need to do is call this and pass it the palette and just simply have it re-index based on the palette that was passed in, because it's already so it's already indexed in the first place. Let's go to that. So here, when we do convert image to indexed, it's looping through and comparing the RGB values of the PNG file to determine how close it is to the NES palette, and converting that over to the appropriate index for the NES palette color, right? And then from there, all we would need to do is, instead of doing this load, we need to re-index the image using the palette that was selected for that particular region of the map. So we would save another list in alongside of our discovered meta tiles that has the palette value. So then, yeah, I think this is a good suggestion. I think this is actually a really good suggestion. The only thing that I'm not 100% sure on right now is we have this tile layer. I can change the opacity so that you can see the regular image, the actual background behind it. So it seems like what we would need to do is create like a dummy tile set. And the dummy tile set is just for setting the palette based on a tile set image. And then here's what we can do in Aseprite. It's kind of really super basic. So there's only going to be 4 color. Wait, how many? 4 palettes. Well, I guess actually no. We could have as many palettes as we want or need, because now we could. Let me think about that. No, it'd still have to be as many palettes as, you know, the 4 palettes. But if we wanted to swap palettes, we would just, you know, we would just continue to use. We would need to have some way of identifying which palette we're swapping in, maybe as an object or something like that. Yeah, you can only have 4 at a time. So, so that means that we are 32 by 8. Index RGB transparent, and then it's kind of funny that we're doing it this way. So we'll just pick some colors that are pretty dramatically different so that we can see what we've put down. Load palette. Let's get. Oh, why doesn't? Palettes. That's the default one. Where'd my NES palette go? I thought it had. I thought there was a. I wonder why. Thought I had one. Yeah, screen tool. It's been a while since I looked at this, so I don't remember. Yeah, I could swear I thought. Let's save this. This is the NES palette. Let's just save that, and then we'll load that here. Load. Okay, cool. You could add a trigger object. Yeah, that was kind of what I was thinking. That in the object you could identify the source, you know, which palette you want and which palette it needs to replace. So, all right, so we've got a pretty wide gamut of colors here. So let's go for some bright ones for the purposes of what we're doing here. Where are my tools? Rectangle tool, filled. Is that 8 by 8? Yeah. And then, so all I'm doing is creating rectangles that we're going to use for this tile set to identify which palette it is. And it's, we still have to identify maybe in the properties of the map what the name of the palettes are in the appropriate order. But I am fine with that. So NES palette tile set, and then export. What did you export as? Oh, it's already, okay. All right, cool. So let's load that in. It's 8 by 8 and save that. And so this, the purposes of this is just literally to help us with the palette selection, right? Which one of these is open tile set, new tile set, map. Add external tile set. Okay, so let's go crazy here. Let's go back to Jordan's work for a second. So there are, so this is the palette that's appropriate for the water. So let's just say that that's going to be our first palette, and then we just kind of grab everything here and draw. Did that work? I'm not sure. No. Am I using the wrong? I'm using the wrong tool. Yeah. Okay. Ah, yeah. There we go. So I should be able to just kind of very directly. Oh, except you know what? This is the wrong map now. Okay, that's fine. Let's save this. It doesn't really break anything. I just, I forgot we switched to map 1. Or did we? No, we... Yeah, wait a minute. I thought we switched to map 1. Yeah, okay. Sorry. So I forgot about that. So that's tile layer 1, and then we're going to create tile layer 2, which is called palette. And then we're going to give it a 50% opacity. And okay, cool. And this is actually a little bit of a more interesting thing to work with, so it'll kind of prove out the point. Here's our palette tile set, and I'm going to grab this, and I've got the right thing selected. So let's drag that over, and then, oops. Why aren't you selecting the bottom one like I want you to? There we go. Okay. So that's that. And then palette 2 can be, let's see, I think it's the green palette there. So that palette can be for all of this and all of this, and then there's a palette for okay, so he didn't create a palette explicitly called out for the house that we ended up pulling in, but that's fine. That's essentially a third palette anyway. So let's do that. Is it a third palette or is it a fourth palette? I gotta think about that because I don't know. You know what? Let's keep this simple for the sake of my sanity. I don't remember or know if it's actually correct with that, so let's just go with that for now, and then go back and let's select and highlight this portion to make sure that it is colorized to have the right palette. Access is denied. Okay, so now when I'm working on it, I can look at it this way, and then when I need to see the palettes and work with the palettes, I can do that. That's good. And then let's go to the map properties. And then what we'll do is we will do the same thing for all of them, which is we will just have... Oh, you can actually explicitly set a file? Really? Let's see. Let's see how that works. Oh, that's cool. That's really cool. I assume that what that's going to do... Obviously, this isn't the right file, but let's see what that looks like when we export it. I like that it's a file type, because then that means that we just select the file in the editor instead of having to try and figure out the location. All right, so if we go up and we look at the layers of data, assuming that this got updated, it's tile layer 1. That's palette. Oh, okay, because the tile set, right, the tile set is offset when we look at, all right, that's fine. That's not a problem. That's easy enough to fix. Let's look at the properties. Oh, yeah, there it is. So I like this, the way this is coming together. Hold on a second. So let's open up YYCHR. Oh, I closed OBS and Twitch. Okay. Can I export the palettes from here? That's RGB palette. Palette. Type open. Save RGB. Load palette. Save palette table. And save the whole palette table. Can't do just one. What about NES Screen Tool? What I want to do is I just want to go through and modify. Actually, you know what? Maybe doing it as a set makes the most sense, because then you just have one file. Yeah, you can save the whole palette. I assume this is going to be 16 bytes. Let's see. Let's see if that is a correct assumption or not. So there that is. Let's open it up in Fred. Yep, it's just the 16 bytes. Excuse me. Is it easier in code to update a single palette or all 4 palettes when and if you need to? I think it's fine either way. I mean, the ease of doing all the palettes all at once is that you always start at the same place and you always write out the same amount of data, and we could have a a shadow of the palette data in the RAM. Just use the 16 bytes for that and write that all out. At the same time, it's not really hard to figure out where it needs to go. In fact, I believe, yeah, so I have a subroutine I wrote called load palette where it is, let's see, param 1 is the palette to load, param 2 Is the palette in the PPU? So is it actually pointing to load palette 4, stored in PPU 0, palette 4? I assume this is looking in. Oh, okay. So, yeah. So what this? I mean, this is looking at a hard-coded location. Basically, it's looking at the place where all the palettes are stored in the ROM itself, and then it's calculating by just multiplying by 4, based on the palette that you want. You know how much offset it needs to add to the location. The 3F00, it's got to add whatever the offset is that it calculated, which is super easy to do. So I don't think it really matters. Right now it's just happening at level load, but as you kind of alluded to, and I agree that would be something possible, is that you'd want to be able to at some point have something on the screen that trigger, or something in the map that triggers, like let's say this grasslands area palette never gets used after it scrolls off the bottom. You might want to be able to have something here that triggers a load of another palette into the PPU, so that you get the color representation properly done. Transitions in and out of levels, or if the scroll speeds up and a new area is drawn. Yeah, I mean, you know, depending on how the map is laid out, we might have to allow for some additional space to allow the transition of the palette to happen, you know, fully once this is off the screen, right? Like because you don't want to swap it while it's still at the bottom and just about going out, or you get the sort of ugly palette artifacts that you get in games like Super Mario Brothers 3 and stuff, because it uses the 8-way scrolling. So how and where would you store the next group of palettes to load? Well, we would just have baked into the ROM, you'd just have a set of palettes that you need. And you'd identify, like, okay, I need to replace palette 3 with palette 3, meaning palette 3 in the PPU, with palette 17, where palette 17 is just, you know, literally one of 17 palettes that is presumably in this file. So while at first I was thinking, well, Screen Tool is great because it's got just the 4 palette option here. Potentially we might need to merge some to allow for multiple palettes, because while we would load just the first 4 in the beginning, then we would need to we would want to be able to swap them dynamically. Yeah, so it wouldn't load them all, and I think it's just a terminology thing that I'm quibbling over here. So it wouldn't load them into the PPU, obviously, but yes, it would know about them all and write them all into the ROM for later use, and then load them to the appropriate location at the right time. So let's look at the palette here again. We said that we only really need these 2 palettes, so we have the black color here, and then we have like a sand color. You know what would probably be useful is to see what that got translated over to. Do I still have those files somewhere? I do, probably. Too many things open. Okay. No, I don't want this. Where palette open. Let's see if I've got. So yeah, so let's take like this palette as an example. Yeah, so you can see it's selected. That actually loaded in okay. Let's take the second one. So the fact that it's generating these files actually isn't a bad thing. We just need to make sure we have all the right colors. So that sand color isn't in there. I don't know what color that is. Where did that go? It's 1, 2, and this is 3. 4. That's interesting. Okay. Metatile 5. These are interesting color choices that it's saying were selected. That's for the house. Oh, you know what it is? It's because we never use that sand color. Link 7777. You would define them in your code and the build would put them somewhere in the ROM. Yes, that is correct. They would just be more data in the ROM. All right, let's go back to, since we're not using that color anyway, it doesn't really matter as long as it's close enough. Eyeball it. Let's say it's that one. Okay, so palette save. Let's call this, and then what I want to do is I want to look at the, so that's the water one, and then we need the green one that's used for the forest stuff. So figure it's got to be one of these palettes here. That was 7. This is 6. 5. Well, I guess we could do it the other way. If we re-export this stuff, let's just do that. And then we can look at the meta tile in the tool itself. Once we see it, we can see what color it was telling us it used. Palette.json. Yeah, it doesn't matter because we don't need that. It's because it's trying to find the tile set file. So what did I call it? So if it doesn't match and we have that whole thing, then that. So again, we only care if it can't find it, and then actually, you know what? We can just break or continue. If string compare JSON file palette.tsx then just continue. So skip this one. We don't care about this. That's really what it comes down to. That tile set is not. Oh, yeah. Yeah, I just said don't. I don't care about that. Why are you... If not string compare... Oh, because it's... Oh, no, that's not it. Because it's a whole thing. It's the whole path. That's why. Darn it. I just literally just want the file name. Let's do this. We'll copy it. Get file name. JSON file. We'll just overwrite it on itself here. Or even better, we'll do this. And then we don't care about the change of the file extension. We just want to say, if it's this, then continue. Otherwise, we'll copy it over with the full path and replace the extension and then check to see if it exists. I think that's going to solve that. Seems like a reasonable approach to that problem. Yep, it ignored that, and now we're dealing with something else. Why? Load map, discovered meta tiles. What is your deal? You're looking at something again that you're not supposed to. Meta tile 2, PNG. Replace the extension with meta tile. Tiger image. Where is the image that it tried to load? PNG file name. Image. Did you load properly, image? No. What is your deal? That's weird. So that's the file. Oh, I wonder if it doesn't like it because I have it open. No, I don't have it open because that's the PNG. I didn't delete that, right? No, that's still there. Okay. That's weird. So the image is good. Oh, maybe there's some sort of corruption going on here. Next meta tile. Okay, that's all. 3, 4, 5, 6, 7. Oh, wait, why did I go back to 1? Meta tile count 2. What is it doing? Is this because of the secondary tile? Yeah. Okay, so this is, I think, just because we added another tile set. Meta tile count 2. Actually, why would it? That is weird. How would it do that? JavaScript file got loaded. Tile sets is not 0, so we're here. And then once we're out of that, we get the layers. Oh, because there are multiple layers. That's why. Let's take a look at the JSON file, because that's the problem. It's ignoring the secondary tile set, but it's not going to be ignoring the second layer, which it should, because the name is palette. That's really the issue here. So string name get value. Oops. Not name compare palette. Okay, so if it's not the palette and it's not a tile layer, or it's not a tile layer, then it can go wait. Compare return 0 if it's true. So it's got to be not that and not that. Or no. These negative cases, it's got to be not this value and this value. It has to be false. I guess I could write this as a standard compare since it supports that, right? So we could say if type is this and name is not that. It's a lot more sensible to understand. Okay. So this shouldn't crash now, hopefully. So there's the PNG being loaded, which is good. And we have metatile 1, metatile 2, metatile 3, metatile 4, and crap, why is it doing that again? You should not be doing that for any reason. Okay. So the type is tile layer and the name is not palette. So we go in there, and then the type is tile layer and the name is palette. So it should not go in there. Okay. So now the metatile count is only 2. If it's only 2, next metatile is 4. What is metatile count referring to again? Tile sets size. Okay, that's why. So it's going based off the number of tile sets. And that's not correct because we skip one of the tile sets based on the fact that the name doesn't match. So what I actually need to do is we can say in here if name is equal to palette, metatile count minus, right? And then continue, just in case we want to go back through that loop for some reason at some point here. Like if we end up needing multiple layers, but we don't. So for now, but we do need to reduce the number of the metatile count because there is only one. And that was what was causing our problem when we come in here and we loop through twice, which is definitely no good. And so we should now just get the metatiles that actually make sense, of which there are those 4. And then we're done, and we're done, and we're done. Okay. So all of that to fix this nonsense and that, and I don't care about that. Okay, so cool. So that fixed the problem we were having. And then now we can look at it in here and see the colors that it chose based on sort of its closest matches. So that's 12 and 22. Let's see what... the reason we're doing this is because we're basically compositing. I think what we'll do is kind of have... Well, maybe I'll still do it this way, but maybe Jordan can choose them, the artist can choose them beforehand, but where did NES Screen Tool go? Did I close it? I guess I closed it. All right. Okay. So let me reopen that palette that I created and look back at this. And so we chose 12 and 22. And that's color 12 and color 22. Okay, so that's fine. And then for the grass stuff, I think it's the reason I wanted to do it this way was because it's a little bit easier to see visually, like what the palette is coming from. So then we have this other palette here, which has OC. OA, where is that? OABC. OC and 29. So 2 is over here and 9. So that's that color. Is that enough for that palette? Yeah, because the only other color is the sand color. So what I'm thinking we would do is if we don't supply a palette file that it can use to correlate the palettes, because I could imagine a scenario where well, maybe not. It's kind of a chicken and the egg problem. Like if we have a palette file to supply, we can use that to reindex the image based on these palettes, right? But if we don't, or if we don't know what the colors are going to be until we're processing them, then how do we have a file, right? Not 2C, what is that? That's 0C. And then I put it in the wrong palette entry, which is fine. Palette save. So if we go now to this and we choose that palette file, that will then correlate properly to what we want it to. And then we can export this again. And if we turn this back on, this is all set. Is this set right? Yeah. So then let's see. So then the next thing we need to do is, like I said, we need to keep track of what palette it said we should be using in the map. Now we've basically told the map, hey, ignore, or we've told the tool, I mean, to ignore what's in the map. So now what we need to do is we do need to know what the value is in the palette layer. We also need to know what the offset is for the palette layer, right? Because the tile set that's used is offset by the GID of the palette tile set here. So we would just subtract that number here. That's not a big deal. So if we have that tile layer, the thing is we want to get the tile layer for the palette first, so that we have access to it for when we process this, right? Because what we want to do is, as we're processing these tiles, so we process these tiles, you know, and create one meta tile, I can look at what palette it says is in there and then store that value there. Although I guess I could cheat and just say whatever the top left corner color palette is, that's what we're using. Maybe that's the better approach, and then that's kind of the rule that it'll follow. It won't bother looking at the other ones. Let's do that because that's going to be the easiest, I think. All right, so, and then that way there's no interdependency between the layers, which is what I was concerned about and what I was talking about when we were doing this. So if there are two tile sets, we're going to iterate through them, and where do we ignore it if it's called palette.tsx? Okay, so if that's called that, the only thing we care about is the GID. So we need to know what first GID is for use here. So we'll say no, not there. UN16 palette first GID equals 0. And then we say in here, we have that, and we just need to get the value of that. So if we look at that, that should give us the value 1441. If I didn't do that incorrectly. Oh, I have that open. Let's close that. Okay, let's try that again. Cool. Okay, great. So then what we want to do is when we go to here and we see that then it's equal to palette, we want to do a similar thing. Can I do that over here? I think that's going to work. So this actually might work out better than I thought it might. In terms of the code structure. We're gonna subtract that, and then we're gonna say processing palettes equals true, create that Boolean. We'll do that right up here. And what that's going to say is that once we're inside this loop here, if process palette, we're basically just going to do whatever we need to do and then continue and ignore the rest of this code, because this should be a lot simpler than what we're doing here. Here we're like looking at the tiles, we're checking to see if we've got a meta tile that matches that already, and if we don't, then we add the new one and all that other stuff. Here we just want to record what that value is in the map buffer. Oh, this is a problem. Hold on. I don't want to modify the map buffer here. Is it possible? Is it possible? I'm wondering if it's possible to get the data. Oh yeah, of course it is. I'm doing it already. So don't touch that. If we're doing this, then yeah, this. So this is where we're reading the values into the map buffer, which we don't want to do if we're here. If we're processing the palette. And same thing with this. We can move that here so that's isolated. And then all we want to do is we want to say data get, and then it's x plus y times tile width. That'll get our value. Convert to UN16. So that gets the value of the palette at that moment there. And then we just need a corresponding buffer that works like our attribute table on the NES essentially, but for this big map. I'm trying to think. Well, all right, so that, if we have that, wait, do we even really need to do this? That gives us a list of what palettes need to be selected for each of those meta tiles. How, when we write the map out, we're doing a straight mapping of the tile to its palette. So that's the bigger issue now. Like meta tile 1 maps right to palette 1. Right, because we don't have any. We do have a way that we're kind of looking up. We were doing that, but we got rid of it because it was unnecessarily complicated, and I just kind of hard-coded these map palette values to say just, you know, use palette 1, 2, 3, and 4. But what we really need to be able to do is now is say which meta tile maps to which specific palette. I mean, it's actually, in a certain sense, it's like we have the attribute table all written out for us. I think I have to look at the code. I think we're just literally using load attribute buffer X and calculate our end attribute index. Flip the bit for the new tile. Populate attribute row. Load the attribute buffer and the attribute mode, or with temp, store that back into the attribute buffer at that location. Increment X, compare it to temp2, and then branch if not equal to populate attribute row, and then we flop the attribute mode settings, and then we talk about what we're actually changing, right, because we do not update the attributes all at once. We do half and half, because otherwise you'd get the same artifacts from attribute changes, since we're updating 16 by 16 and not 32 by 32. So, but where is it getting the value that it's actually storing in there? It's masking it, and then it's ORing temp. Temp is flip the bit for the new row. Temp is going to be whatever the mask needs to be, or no, that's whatever the value is supposed to be for the attribute at that time, and then we store it back in. So we take whatever it is, we mask the appropriate part out, whether it's the top half of the full 32 by 32 attribute portion of the map, and we OR the value on of what the new value is supposed to be. So where does that come from? Store that in temp. Meta tile flag. Load new tile row. Populate single tile. So it does that until we've populated the row. Flip the bit for the new row. Skip repeat attribute update. Otherwise, load A with 1 and OR it with the meta tile flag. Store it back into the meta tile flag. Load BG loop meta tile. I think that's whatever the value of the meta tile is that we're loading. Yeah, so, and then we do the lookup of what that value is versus what that is normalized versus what tile it actually is, because if you remember the way the asset tool was working, because we had multiple tile sets, it was based on the tile sets used in level, it was removing the gaps between tiles in order to make the map have a contiguous set of indexes, but then the actual tiles weren't always contiguous, so you'd have this lookup that it does that we can get rid of at some point. But there is nothing, it is just using literally whatever your background meta tile is. There is no lookup for what attribute it should be, what attribute color. So that's the part that we're gonna have to fix. I don't think I have it in me to fix that tonight. But what we can do, because attributes are such a pain. But what we can do is we can make use of this lookup that we were already building and make it look up not what the tile should be, because that's no longer something that needs to be. Let me think about that. Does that need to be compressed down like that? For that particular map that we're looking at, if we just have the one map, no. If we have multiple maps, no, we could just change the offset that we're looking at for the map location. Like right now, I believe, I want to say we're just like hard coding, looking up the actual data at like map 1 or something like that here. And I don't remember where that is. That's fine. But if we just change that, or sorry, not, yeah, I mean, that's part of it too, but we could set an offset for the tile set. Well, but then if they're shared tile sets, okay, so that's actually not going to work. Sorry, I had to kind of talk through that one on my own to make sense of that one. So let me explain real quick, because I just was kind of sitting here muttering, and I don't know that anybody followed that but me. So the way that I had done things was that we said, okay, if you have a bunch of different tile sets that you're loading in to the ROM, just pretend that there's a bunch of tiles in that, right? Your map might only use, you know, that one, and then another map for another level might use that one or that one. That was how it was working when each tile set was its own meta tile. Now what we've done is we've essentially kind of said, okay, well, this map has actually that was still valid. This map uses these, and that's always going to be the case, because we're generating these dynamically after analyzing this. So there's no gap, because why would there be? We wouldn't generate meta tiles that aren't used. If we have another map, which we will at some point, it will potentially have its own meta tiles, right? The thing is, though, that realistically, if you think about this, we don't want to have, like, if this is tile A, right, that looks a certain way. Let's say we're using this like this, and there's another tile called tile that looks like tile A over here. Well, we don't want to have two of them, because that's going to waste ROM space on the cartridge and space that the PPU could use for other tiles. So on the back end, when you look at the character ROM, what you should see is that there's only this one tile here, A, and that's this one and that one. For now, I'm not worried about doing that, because we don't have multiple levels, and I'm not necessarily worried about the problem of the space at this very moment. But moving forward, when we have another map and we have to consider this, we will write something that will turn, the individual, will analyze the individual meta tiles and turn them into, reduce them even further, from this to, where we have this as a 16 by 16 image that we're storing off uniquely, and instead say this is actually, a collection of just 4 numbers, like 0, 1, 2, 3, and 0 refers to that same tile, right? And then the asset tool knows how to build that up. But that means we are doing a lookup, because while this will be, this is a meta tile. Well, I guess it actually, you know what? It's built. How is this built? This is built to do a lookup that says the whole meta tile has to be unique. So actually, that scratch what I mean. The idea is correct, but what I was going to say was that we could reuse the lookup stuff that we have today, and that's not true either, because it's built around the meta tiles being unique. And really what it needs to do is it needs to look up based on whatever the value is here in the meta tile definition. So it's got to say, like, okay, I've got a meta tile. Let's say this is meta tile 5. This is meta tile 1. 1, 2, 3, 4, 5. Let's call this meta tile 6. It's got to see, okay, for meta tile 6, that is going to be, it's got to look up, it's got to look up what string of tile numbers it's using. So it's going to be, like 1, 17, 18, 19, versus this one where it's 1, 2, 3, 4. And then that's how we choose what tile, because then from there, we just know what tile it is based on indexing into the tile list. That's going to be just the raw tile number. This is going to be, well, actually, you know what? You don't have to do a lookup for that. As long as you know. Yeah, sorry, because some of this is like I'm just thinking this through as we're going, so I hadn't really considered that. So as long as we're talking about something that we're not trying to process separately and then bring together later, if we process these maps together and they come in order, we can have a bunch of data that defines what the meta tiles are here. And then in this map, it can say, okay, this is a 6 and a 7 and a 6 and another 6 and another 6. And this can be, meta tile 1 and blah, 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 blah. There's no lookup that has to happen. The only time we might run into a problem is if we hit that limit of the 255 meta tiles, right? Because if we have 255 unique meta tiles, then the problem will become that that we will not be able to store the index into the definition of those meta tiles as far as what actual tiles make them up. We will not be able to store that value as a single byte, and so suddenly we're going to double the size of the data that needs to be stored to find those values, which we don't want to do. So extra care will need to be taken that as we process multiple maps together, we look for, is this meta tile actually the same as this first one? Maybe that's why that A tile is the same. And so 1 and 6 are really just going to become 1 and 1 to help further reduce that. But again, that means we don't need to do a lookup. It's just making sure that we have all the data all the time when we process it together. So that's fine. And for what let's see. So for what we're doing here, So what we're doing here, what we're saying is we're saying, okay, if we get a value of like 1, we know the beginning of our let's say, yeah, we know, let me move all this stuff off here. So the way it works right now is we say, okay, we have meta tile 1 that's in the map data, and here's our character ROM in the PPU. We begin, let's say we begin at the beginning. It's not true because we have some data at the beginning, but let's just say for the sake of ease, that's what we do. We say it's just a simple operation. We say, okay, every meta tile is 4 tiles, so this is index 0, right? Because it's 0 indexed. This is index 1. This is index 2. So we're just multiplying by 4 and saying, oh, yep, here's 1. And then depending on which tile we need, we grab, you know, these are the top 2, these are the bottom 2. That part, that part is, let's see, is that okay? That part is okay, and that part works, like I said, for the same reason as I was talking about before for this. Where the problem is we said, okay, simultaneously, we have these palettes. There are only 4 of them, and we're going to load them up with whatever values we're going to load them up with. And right now it's saying, okay, if you're on meta tile 1, you're using palette 1, which is this palette, right? Because it's palette 0, palette 1. Which is a problem, because what we want to be able to do is we want to be able to say palette 1, meta tile 1 uses whatever palette it uses, and then meta tile 2 might use a different palette. Meta tile 3 might use the same one. Meta tile 4 uses maybe the first one, and it's the only one that uses that first one. So we don't have anything right now that's like a global lookup for the meta tile mapping to the palette. So I think that's where we need to go. And so this functionality that we were working on just a little bit ago before I launched into all this expository exposition, whatever it is. This data needs to be stored off so that we can build up the mapping that says meta tile 1 uses this palette, and palette 1, and meta tile 2 uses palette 2, and meta tile 3 uses palette 0, and then from there it would need to store that in the ROM as a lookup table, which is that's not that hard. It's one extra step because we already have the meta tile value, and we're just using that to determine what the palette value should be in the attribute. And what we need to do is do a lookup to swap that value, and then that would solve the problem. Now, if we do what we're talking about here, we get the palette color, but that doesn't correlate it to a meta tile. We have to do that at the end. So what we need is we need another buffer to hold, to have and to hold our palettes. So that's the discovered meta tiles. That can support up to 4,000 discovered meta tiles, but realistically, we'd be in trouble if we exceeded 255 like we talked about, but what I really want to do, but then that brings us back to, well, actually, no, it doesn't. We don't have to do that right away. I was going to say that brings us to, that creates a problem, because then we need to know, creates a problem because then we need to correlate the actual values of the meta tiles to the palettes, but we can do that at the end when we're actually creating the meta tiles, because when we loop through, why is this complaining? Did I do something wrong? Let me finish that thought. So when we're writing out the meta tiles, we know what the we know what their index is, and then we can look for, can't we? No. So we do actually need to correlate it because we're discovering the meta tiles dynamically. Yeah, because we're discovering the meta tiles dynamically and generating them dynamically, the only way we would know how to then correlate them to the appropriate palette would be to know which meta tile had already used. Could we just brute force that and just kind of be like, the first time we encounter the meta tile, yeah, we could do that. I was going to say, if we wanted to be really careful about it, we have to really look at, okay, this meta tile got generated at this location, and then the palette was there at that location. But realistically, all we have to do is iterate through the entire map and just kind of, it's not the most elegant solution, but it would totally work. You just iterate through the entire map, and every time you encounter, for every meta tile you encounter at the location, you look up at what palette is selected in the other buffer, and you just store that in an array. And if there are inconsistencies, that'll be a problem, but you'd see that in the game. My concern was, like, flagging the inconsistency or avoiding the inconsistency, but I don't think it's worth the effort of doing what needs to be done to be able to correlate those two and ensure you have the data in the right order and stuff like that. So really all we want to do is create a buffer that is the appropriate size, which is like half the actual size of or a quarter of the size of the map, because it's half the width and half the height of the map. So let's have this pointer called attribute grid. We will allocate that once we know what the width and height are. We don't know what they are. Where do we know where they are? What they are? We know what they are here. So if I guess this is only important if we are processing the palette at this point. So let's do this in this order. Okay, so then this is attribute grid is equal to, actually this can't be a character array. we should be using N16s because depending on the offset, it can be, and the number of tiles, it can be pretty large. So size of N16 times T width divided by 2, and then T height divided by 2. Right, so it's just got to be that, and then, oh yeah, I got to fix the casting here. Okay, and then when we get to this point, we just are basically going to say attribute grid is equal to, this is going to be x over x divided by 2 plus, wait, this is going to be x divided by 2 plus the y has to be divided by 2 and the height has to be divided by 2, right? Sorry, the width has to be divided by 2 for our stride across the array. So that will process. Let's take a look at that. You can forgive maybe my my apprehension, but that looks really gross and gnarly, and I'm not sure that it's right. Meta tile map, undefined. Where'd that go? Meta tile map. What? Did I move that around or get rid of it somehow accidentally? What did I do? Oh. No, I didn't even see it. I'm allocating it inside that Boolean area here. Even though actually I shouldn't be. I should be doing that. Oh no, wait, I should be doing that. If not processing palette, right. It's just that it's defined there, which doesn't help if you're going to use it elsewhere. So that defined it, that just needs to be, okay, right, cool, so that should fix that. That was just a weird scope thing. Alright, so now if we go back to the code, that breakpoint is set. Let's take a look at the attribute grid and see. Oh, I didn't realize that breakpoint was still set, or that one. Okay. Yep, there's attribute grid, so let's see. Y x is 2, so that would be 1 plus y is 0 plus the height. Oh, it's not plus, you dummy, it's times. All right, let's see if that fixes it. All right, so I see value already, A105. Actually, it's probably 5A1, which is I think 1441. If I remember right from the last time, 5A1. That's not in hex view. 5A1. 1441. Okay, cool. So 2 bytes being set. All right, cool. And then, oh, you know what we can do here that would also be helpful is we can subtract the palette GID so that we get the actual appropriate value here for that. Instead of, oh, actually, so if we're going to do that, then this doesn't need to be Uint16, right? Because if we're going to offset it and subtract the GID, we know it's going to be a value from 0 to 3, so it can be an 8-bit value instead. Not that it's really the biggest deal in the world, but why waste the memory? All right, so that's that, and then from there we're good. We just need to, we're getting that as a 16, and then we are subtracting the GID, oops, and that should be fine. Okay, so that's 0. That's 0. Let's see here if we, it's going to be a while before we get anything that's interesting because all the palette colors were kind of set. Let's do this. Let's change it up for the purposes of our testing just to make sure that that is working. Okay, cool. So that's saved, and let's export. Oops, not that file. Don't want to overwrite the project file. Okay. So now, let's go back to this. Let's restart it. Let's make sure that we get what we're expecting here. And then I think that'll work. What's that? 1. Yes. Okay, great. So that's generating our grid properly for the attributes. So what we'll end up with is our full attribute set at the end of that loop. Assuming that there's no issue that's going to cause it to crash or something like that, but I don't think we'll have that problem. Let's see. Cool, that looks pretty good. Yeah, and there's the other palette 1 in there, and we didn't use any other palettes, so I think we're good there. So now the next thing we need to do, now that we have that, is, like I said, once we're done here, we have the attribute grid configured. Let's see, so we've got our discovered meta tiles. We have the map remapped based on the meta tiles that we've discovered, and we copy it over to the map buffer from meta tile map. Here's where we can do double duty, which is we can create our lookup. And so what we want to do is we want to say, I guess we'll create a double of this, but it won't be obviously Uint64s. It will be, this will be meta tile attribute lookup. So basically what we're going to do now is as we loop through the map and remap it to the meta tiles that we've created, or sorry, we're copying the map based on the meta tiles that we've discovered back over to map buffer. Where is that code that I was just looking at? Yeah. So we've created meta tile map based on the new meta tiles, effectively mapping the looser tile definitions to the meta tiles that you essentially see these tiles conforming to in the grid. And now we have to copy it back over to the map buffer to properly represent the map in the metatile format. And so what we want to do now is we want to have, literally this is kind of like stupid, but what we're going to do is we're going to say, okay, whatever this value is for that particular meta tile, we're going to have we have our, what is it called? Attribute grid that has the value of the palette in it. So just as we're going through this and taking the metatile map value, right? We're saying, okay, what was the palette value that we discovered there? And we're storing it into this lookup. And so when we're done, we'll be able to say, okay, for metatile whatever, it used excuse me, it used this palette. So let's confirm that that's correct. And then I think we'll call it here, because, well, it's been a long stream. We're at just about 2 hours. So I could keep going, but it's getting late for me, and I'm not sure how much it will help to just keep going. I might do some more coding tomorrow by myself and record that and kind of get to the bottom of this. Okay, why did attribute grid, why is this, I'm confused. Attribute, metatile attribute lookup has CD, CD, C. Well, yeah, of course it has CD for everything, but why is that? Did it go, something get overwritten here? Let's go back. Let's look. The CD thing means something went wrong. It was looking fine. It was looking fine in here, and then when we get to this, it is not fine. Why is that? It shouldn't have gone out of scope, because that is defined at the top, right? Metatile attribute lookup. Attribute grid is here. So what gives? Let's go back to here. You know what? I know what happened. I think it's probably reallocating the memory, because those CDs imply that that memory is uninitialized. So we must be having, yeah, here it is. So I'm allocating the memory when we're not processing the palette, which doesn't make any sense, obviously. Which means that the first pass through probably didn't have the proper memory initialized. It was just a mess. So that's not correct. So this should look better now. Wait, what? Now it didn't process anything. Compression is null. Maps compress, get the data. Process palette is true. If not process palette, do this. and then allocate the meta tile map. Otherwise, should allocate the attribute grid. Okay. Never got here. Did it not export it because it's not visible? Is that a thing? That would be weird. Not the weirdest thing I've ever seen, but definitely weird. What is going on? Oh no, okay, that's fine. Right, okay. No, that's fine because that's the first time through. Oh. Okay. Right, if we haven't hit the palette processing yet, then we can't do this. So okay. So all right, we gotta make this scope of this last for a little bit longer because we do need both sets of data to be there at that same time. And I thought that's what I was doing, but I forgot that we were at a point where we were just processing the individual layers. So it helps when I pay attention to that kind of stuff. So we are here, and then we should be okay to process it now. Like when we come in here, if we're not processing the palette, we do our usual stuff. Otherwise, we get the attribute grid set up. I think that's all good. And then we have both at the end, and we should have things that make sense. So let's see. Yeah, there's our attribute grid allocated now, and then we're just going to go through and populate that as expected, right? So yeah, that got a value that makes sense. So did that. Okay, so let's go out of this whole cluster of code and get rid of that breakpoint. Okay, that's all set. So we're gonna initialize map buffer now again, and then we're gonna loop through and we're gonna actually populate map buffer with data that is correct based on the meta tile map, and then we are going to look up, set our lookup stuff correctly, hopefully. So this will say meta tile attribute, meta tile attribute lookup. Okay, so yeah, there is no meta tile 0, which is fine. So now we're just going to keep getting a string of the same values. What I just want to check is we shouldn't have any sort of weird. So that's 1 and then 0 and 0 and 0. And does that make sense? So meta tile 1 is going to be this water, which is palette, set to palette 0. Or wait. Meta tile 1 is set to palette 1. Attribute grid. The attribute grid has 0, and then oh, because I okay. Right, because I messed up the palette here. So, okay, so then that would mean meta tile map I for all those ones, we set the palette. Why is the palette set to 1? It's not going based on... It's not based on like a greater than or something like that. Like which one is the largest? It's just going based on the last value that was seen. So let me make sure I'm looking at the right buffers here. So that's the lookup there. And my metatile map has 1 that it's setting for the lookup, which makes sense. And then it's saying, okay, attribute grid, you're just a set of values for what the palette value is. And so it was 0. Let me get another memory window in here because I want to kind of, I guess we could just walk through it. I'm trying to walk through it visually by looking at the RAM, but it's kind of a waste of time when I can just do it in the debugger. I've got metatile attribute lookup. So that's our lookup, and metatile map is right. We're in the, I don't need that. Okay, so that's ones across the board, and I guess I do need another memory thing because I want to see what the value is. Here, go over here. The diagnostic stuff is so unhelpful right now. I don't even need that. Wait, where'd my other memory window go? No, memory window, where did you go? Ah, come on, Visual Studio. What was that all about? Oh, okay. I see, it got hidden away. All right, so I want it in the top, please. All right, where did they go? Oh, you're moving the whole thing? Why? I just want this one. You go up here. Oh, Lord. Come on. What? Yes. Okay. That's that. And then you, can I put you, I don't want to add it to that. I want it to be next to. No. What is it doing? Okay, fine. If we have to do it that way, sure. All right, and then you're not going to let me do... Okay, go over here. Now stop it. Now, all right, I don't know what any of these buffers are. Metatile attribute lookup. Okay, so that's the lookup, which hasn't been populated. We have our metatile map, which has been populated, and then we have our attribute grid, which has also been populated, and you can see this is just the one anomalous one here. And so let's see, if we have the attribute grid that has the value 0 for index 1. So for the lookup, we're going to say index 1 for value index of 1 over here, we'll have the value 0, and then it will go to 1, and then it should just go to 0 again. Not sure, unless there's something in the map that I'm not remembering that I messed up. Doesn't look like it. It looks like that's all consistent to me. Okay. So, let's walk through this here, shall we? So it set it to one attribute grid of meta-tile map of 0. So 0 in attribute grid. No, 1. Oh, wait. Yeah. Yeah. So we're saying we want whatever the value is for the attribute grid at that point to map to whatever the meta-tile corresponding value is. Yeah, that's why. Mostly it's because I'm tired. All right. I'm pretty sure that fixed it, but let's just confirm. Oh wait, I had that already. I want the lookup. Meta-tile attribute. Meta-tile attribute lookup. Okay. 0, yes. And then it's going to become 1, and then it's going to go back to 0, and then it's just going to stay 0. Okay, and then if we zip through there, we have meta-tiles. So 1 is 0, and then 2 is also 0, which, yes, that's correct, because that's correct for the wavelet. And then 3 is 1, which would be our grass, and then 4 is also 1, so that is correct. So we've properly done this for this level now, where we know we only have 2 pallets. Now, if we needed more pallets, we could add the additional pallets to this to color code it yet even further, and put it on the appropriate locations, and then we can do the things that we need to do color swaps and stuff like that. But what that would result in is that the additional meta-tiles like meta-tile 5 and 6 would have yet other palette. Actually, you know what? No, we wouldn't do that, because as we were talking about before, sorry, like I said, I'm tired. Yeah, so we wouldn't do that because we would have to indicate that we want to swap a palette in for palette 4, which would mean that then you would use palette 4. It's going to be a little bit tricky to keep track of for any palette swapping we're going to do, but that will work. And that's all the storage we need, because that's the maximum number of meta-tiles we have. We probably want to zero out the lookup for the purposes of just having 0 for the palette for the blank meta-tile, which is fine. We can do that. Where is that lookup? Yep. Okay. So that puts us in a place where now what we have to do is write that lookup somewhere for the ROM, and basically, like I said, let's walk through that real quick. So right now, when we load, let's see, metatiles is what? Metatiles is the actual, yeah, metatiles is the actual tile. At some point, or sorry, the actual offset into the tile set that we would need to use. Now, at some point, that will change to a lookup to find out what the individual tile is. We're not doing that anytime. We're not doing that right now, or even in the next stream. What we would need to do is, now that we have that value, and we know that that's what we're doing for our attribute configuration. What we need to do is we need to, let's see, so temp is going to have the value that we actually are putting in there. Where are we storing it? So yeah, so there, so you see how it says temp has our base offset? That's the base offset into the meta tile. That's what we're using. That is what we, let's see, are we updating that anywhere? Jump to skip repeat attribute. So load A with 1, or the meta tile flag, store it into meta tile flag. Load A with this background loop meta tile tile. Set the carry and subtract 1. And then store it into temp, and then shift it twice, so multiply by 4. That's like actually the real tile, because we're multiplying by 4 to determine, yeah, so that's the actual tile. Where is the attribute value that we are using? Is it because we skipped this stuff? No. Load a attribute buffer and the attribute mode, or temp. Shift left 4 times. That's what? 2, 4, 8. Oh, because, right, depending on how we're doing the update. Oh, right. That's what we're doing. Okay. All right. So I should probably update this. Because it's confusing, and I totally forgot how this works. So basically what we're doing is we're loading the value, we're subtracting 1, and then depending on how we're doing the attribute update, we are shifting temp, or we're not. Like, we're shifting it. Well, we're always doing that, but what we're doing is we're taking the value of temp, the meta tile, because it was always because the palette was directly correlated to whatever meta tiles. So you could only have 4 meta tiles, or you didn't have the palette wouldn't work. It might be easier to see it in the calculator. What I was doing was, like, if you have the value of 3, right, there it is in binary, 1, 1. I was shifting it left twice. Right, and so the 1, 1 becomes 1, 1, 0, 0 because it got shifted twice. And if the value was 3 before, we were taking that and then putting the 1, 1 back on the beginning so that we get 1, 1, 1, 1. No, 1, 1, 1, 1. So we end up with 15. The reason we're doing that is depending on how we're updating the attributes, we may or may not need these bits. Like there's a whole other thing that it's then doing. Like if the mode, the attribute mode where we're updating is the bottom half, not the top half, then we skip doing this shift left because we only need the value that we are changing the attribute values with to be in the bottom 4 bits. But if we are doing the upper attribute area, we have to then shift the values by 4 more. So if we do left shift 4, what? No. 1, 1, 1, 1, and then left shift 4. You see they go into the upper part of the byte. And that's what we would, because that's what we're then using to, where is it? We're doing this OR here at this point. We're taking whatever was in the attribute buffer and we are just like, we are removing, using this and we're bit masking out whatever we need to overwrite, and then we're just shoving these bits into, so like for this we would be updating the corresponding upper 4 bits of whatever was in the attribute value before, and not touching this. This value for attribute mode would be 0, 0, 0, 0, 1, 1, 1, 1 because we want to clear out what's in the top 4 bits before we put these in, because the OR won't remove anything that's set. It's just going to set stuff that's not set already. There was a whole long set of streams where we were working all of this out. I just totally forgot how this works. So I should probably make a note of this because it took way too long for me to remember, because it's been so long, mostly because I've tried to not look at the attribute stuff at all because it's so messy and gross. Okay, so let me make a comment here for next time. We'll talk about what we're going to do next time now that I remember what this does. So after updating the index to properly reflect the palette value that we want, double up the bits in the lower nibble to make to start setting up for attribute updates, right? That's what I was saying before, right? So we shift it by 2 and then we take the value and we OR it on so we have the same value in the bits, and then we save that off, and then depending on the attribute mode we will mask off one portion of what's in the attribute buffer and then OR on the value of temp either as is or after shifting it by 4 into the upper nibble of the byte. Okay. That makes a lot of sense. And so what's really cool is, thinking about this is actually not that hard to fix. So we have this thing here where we've subtracted the value from we've subtracted 1 from temp. That gives us our meta tile and an offset that we can work with, because all the meta tiles start with an index of 1 instead of 0, because the 0 tile is essentially no tile. What we want to do here, we can make a little note actually, is to do for next stream, at this point temp is the value of the meta tile index that we want to use to, not sue, use to search into the palette lookup table that will be saved for all meta tiles. This will tell us what value to store into temp and use going forward to set the attribute properly. Okay, so it's a really simple lookup. Once we get the data exported and into the ROM, we take this value of temp and we use it simply as is as our index into the lookup, which will give us a numeric value from 0 to 3 that tells us what value should be used for the value of temp moving forward here. And then that's it. Then we should have our palettes working properly. So with all of that said, I want to thank all of you who stuck around and watched this longer stream for joining me. You can reach me on Twitter at Clairvis. You can reach me on I almost said Nintendo Age out of habit. Video Games Sage. I am Zelius on the Discord, and also Clairvis on Discord in general. So you can reach me at through either of those. You can reach me through email, zelius@gmail.com. No, Martin, don't apologize. You can't see this on the screen right now, but MDTA UK apologized for throwing me on a tangent, but it's not really a tangent. It's actually a really great idea. So thank you for saving me from myself and implementing something that would have been potentially more complex and would not have bought us much. So this actually worked out really nicely. But yes, if you feel so inclined, as some very generous folks have, I have a Patreon and a Buy Me a Coffee. The Patreon, is just another way to reach me. And I am thinking of doing sort of a video chat with the folks there, just to say thank you for their generous support, because honestly, I still am kind of amazed and grateful that they are on there. So if that's something you're interested in, certainly feel free to stop by. The game is for pre-order on Twitch, not Twitch, on itch.io. If you're interested in getting access to some of the source code, I can give you access to the repo, which I will get around to updating with this latest stuff here soon. It will not give you access to the assets, but it will give you access to the core engine and some other stuff. So if that's something you're interested in, and then eventually it'll give you access to the game ROM, once the game is complete, and potentially the opportunity to get a special limited edition physical cartridge that will be open to only people who have pre-ordered it through itch.io. So I think I covered everything. I feel like I did. So thank you all for watching and your support and asking questions and stopping by the streams. I really appreciate it. I'm glad people get something out of this, and have a good night, and thanks again. See ya. Have a great weekend.